بسم الله الرحمن الرحيم. This is teacher Momen from Al-Hijazya school, and we have a science session today for grade 8. It's about chapter 3 in our second textbook for this semester. This chapter talks about electromagnetic waves. So, before getting started with the chapter, I expect from each one of you to know the definition of each, or understand the definition each one of these concept. Okay, now what you have to do before getting started with the chapter is to understand the definitions for these concepts. So let's get started with chapter 3, lesson 1. Chapter 3, lesson 1. It's about the nature of electromagnetic waves. Now, we studied before about the sound wave, and we said that sound wave related to mechanical wave, and it's longitudinal wave. Okay, now the light wave is something different than the mechanical wave. Okay, the light wave depends on two things. Okay, and it needs two things to be created. We will talk about it later on this lesson, but first let's see what do we have here in this lesson. What goals do we have in this lesson? First one is, what makes up an electromagnetic wave? This is the first goal. Yani you have to know what makes up an electromagnetic wave. طيب, the second one is, what models explain how electromagnetic wave or waves behave? Models. We have two models here. You have to know each one of them. Okay? You have to understand each one of them, and you have to know an example for each one of them. This is the goals, or these are the goals of our lesson. So let's start with what makes electromagnetic waves. Electromagnetic waves are made up of radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-ray, and gamma rays. Okay, now look at radio waves. Radio waves have longer wavelength, or the longest wavelength, compared with the other types of waves. Okay, microwaves has less wavelength compared with the radio waves, but microwaves have more energy than radio waves, because microwaves have more or greater frequency than radio waves, and the rest of waves have the same properties. يعني the shortest wavelength between them all is what is the gamma ray. Now gamma ray has the shortest wavelength and highest frequency or greatest frequency, so for that reason it will have what the highest energy. طيب, let's talk about the increasing of wavelength and frequency. Now, decreasing wavelength, if you go from radio wave to, or if you track from radio waves to gamma rays, you will notice that there is a decreasing in wavelength, and decreasing in wavelength meet by increasing in frequency, and for that reason it's increasing in the energy. Forget about the photon. Okay, forget about the photon as a concept this moment only. We will talk about it later in this lesson. Okay, so increasing energy, and we can calculate energy by H nu. This is not your concern in this in grade 8. يعني you will learn more about it in high school inshallah, and we will use this formula, mathematical formula, to calculate the energy of light wave or electromagnetic wave. طيب. Now let's see, what do we have in your textbook. Here in your textbook, as you can see, characteristics of electromagnetic waves. Here, yes, characteristics of electromagnetic waves, of electromagnetic waves. Okay, so here every electromagnetic wave consists of magnetic field and what, an electric field, and both of them are perpendicular each other. Each one of you knows what is the meaning of electric field. Now the magnetic field can be produced by the changing of direction, the direction of the moving particle, and the interaction between magnetic field and electric field gives us what, gives us light or electromagnetic wave or microwave or gamma ray or x-ray and so on. Okay, but here they should be what, they should be perpendicular to each other. That means the angle between electric field and magnetic field should be right angle, يعني 90 degree. Okay, this point is very important. Without this condition, there is no, there will be no what, no light or no gamma ray or no x-ray. طيب, let's see, your textbook is talking about this or it's talking about the characteristics of electromagnetic waves as is a transfer wave that involves the transfer of electric and magnetic energy, and electric magnetic energies came from or come from what, come from electric field and magnetic field. That's it. طيب. Now let's forget about the key sentence here, because yes, we have something important here. Now look, the light or the electromagnetic waves move through the medium. Okay, move through space or some medium at the speed of light. At what? At the speed, at speed of light. This point is very very important. So X-ray has a speed of light, gamma ray has a speed of light, radio waves, light waves, and so on. All of them have what, they have what, speed, the speed of light. Okay, now let's talk about what I explained before in this slide here. What do we have in your textbook about this? An electromagnetic wave can begin with the movement of charged particles. Charged particles, for example, electrons, protons, helium, okay, alpha, gamma, alpha, beta, okay, all of which have electric field. All of which have what, electric field. يعني the electron has its own electric field. The proton has its own electric field. Okay, around them. As the particle as the particles change speed of direction, speed or direction, a vibrating electric field is created. يعني that means the vibrating magnetic field creates a vibrating electric field. طيب, how? By changing the direction and what or the speed of the moving charged particles. And this involve what? This involve the changing of magnetic field to what? To electric field. At that reason, we will have for this reason we will have magnetic field and electric field in what? In perpendicular, in perpendicular what angle between them, or and or they will be perpendicular to each other with angle of 90. Okay, 90 degree or right degree. This point is very important. Now let's talk about the energy of electromagnetic waves. As I said before here, now if we have long wavelength, so we'll have low energy and a long wavelength, low frequency, that means low energy. Also here we have short wavelength as gamma ray, x-ray, ultraviolet, and so on. Short wavelength, short wavelength, high frequency, and for that reason we will have what? High energy. Okay, so what you have to memorize here is the waves in order, or the type of electromagnetic waves in order from lowest energy to the what? Highest energy. يعني you have to know that the X-ray has more energy than visible light, and visible light has more energy than radio waves. Now if we want to say them according to increasing of energy, we will say radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma ray. Okay, I think this point is very obvious. طيب. Now don't forget about the angle, and they are perpendicular to each other to what? To create what? To create electromagnetic waves. Electromagnetic waves. If we want to analyze it, we will have what? We will have a magnetic field perpendicular to what? To electric field, and they move in the same direction, and they move in the speed of light. طيب. Now let's explain how do electromagnetic waves behave. Okay, are they behave like light or like a particle? The scientists have they have two models to what? To explain electromagnetic waves behave. The first one is the wave model of light. Now let's see the model of light. What does that mean? Now if you hear about the model of light, you have to think about the light polarization. What is the meaning of light polarization? Now look at this example, or look at this figure. Now if you have a bulb here, the bulb emits what? Emits a light in all directions. In what? In all directions. Now I put what? Slits here. Slits that what? That filtered the light. Now after filtering the light, I will have the light what? In one direction only. That means the the other directions of light, or the other waves, they have been what? They have been absorbed by what? By polarizer. This called polarizer. And polaroid. And polarizing is the process that make the direction in all that make the light in only one direction. We call this process is light polarization, or polarize light, as you want. Okay, this is the main key idea, to put a background for you to understand what in your textbook. Now, in your textbook, wave model of light. When light passes through a polarizing filter, this is a polarizing what? Filter. Light passes through polarizing what? Polarizing filter. It has the properties of a wave. An ordinary beam of light consists of waves that vibrates in all directions. يعني the light bulb emits light in all directions. A polarizing after acts through it has a tiny slits aligned in only one direction, like like Polaroid. Now Polaroid has what has only has tiny slits in only one direction. Whatever is the direction, is it vertical or perpendicular? The most important thing that here I have the Polaroid only in one direction to what to filter the light. Type to filter acts through it has tiny slits aligned in only one direction. The slits can be horizontal or vertical, as I said before. When the light enters the polarizing filter, when the light enter the polarizing filter, only some waves can pass through it. Only some waves can pass what through it. Not all waves pass through what through Polaroid. Only one wave pass through Polaroid and in specific direction as what as the slits aligned in one in the Polaroid. Okay, that's it. When light enters a polarizing filter, only one wave can pass through it. Only one, some waves can pass through it. The light that pass through it called polarized light. So the result is what polarized wave or polarized light. And this all explain uh, the the light property of wave on wave model of light. I'm sorry. Now this is about the wave model of light. Boys, you have to understand. You have to understand it. First, you have to memorize that models explain how electromagnetic waves. We have two models. First one is the wave model of light, and you have to explain it using your own language, but you have to what you have to memorize or you have to remember and understand this figure so you can explain it easily. Okay, now let's go to the other model. Now the other model is about particle model. So we have two models that explain the behavior or the electromagnetic waves behavior. First one is the particle the wave model, and the second one is the particle model. Particle model like any particle around you. Wave model like what, like light. So we have two models. The second model is the particle model of light. Now let's talk about this particle model of light. This about what the electro or the photoelectric effect. What's the meaning the photoelectric electric effect in language? I'm not going to explain it scientifically first. First, I'm going to explain it in language. Now, photo means light. Electric means what? Means electricity, electric, okay, effect. Now, that means we have photo electric effect, light that affect on the particles electrically, okay, electrically. So let's talk about the particle model of light. Now when we have incident light on a metal, now a metal, as you know, has a free electrons, and these electrons are too easy to be liberated. It needs only energy, and if they gain energy, they will be what, they will be liberated by what, by the incident energy or incident light. So in the result we will have what, electron emission, electron emission. So when light incident on the electrons will be liberated from what, from the metal. Now in the now let's talk about this, or let's explain this in more details, or let's go inside the atom. Now, if we go inside the atom, we will find that the gamma ray or X-ray, okay, or visible light, anything, when it's bounce the inner what, the inner shell electron. We have outer shell and we have inner shell. Here we have two shells. The outer is the last shell, which consists of the valence electrons, and we have what, the inner shell. Now when the light hit the inner shell or inner electron, okay, inner shell electron, what will happen here? The electron will liberated from its what? From its shell. It will leave its shell because it has energy. It has enough energy to get to the higher what? To the higher energetic what? Energetic shell. So this process produce a photoelectron or emission electron or emitting electrons. Okay, or we can call it photoelectron. يعني this process or this model can explain ايش the particle behavior of light. Okay, the particle behavior of light. Think about boys bouncing when two things bounce to each other. Okay, and you will understand this model easily. Now let's see what do we have here in your textbook. All right, these particles are called electrons. The emitted particles here because of incident light are called what? Electrons. Some light can even cause an electron to move so much that is known knocked out of the metal as shown in figure 3. Now this called photoelectric effect. Now again, if I increase the energy or if I hit the electrons by not X-ray, let's say gamma ray, they will what? They will emit to what? To the to a higher outer shell, to higher outer shell. They will get away from what? Away from their inner shell. That's it. If we increase the energy, so the electron will go to the higher shell according to what? According, and this depends on the binding energy between the nucleus and what? And the inner shell electron. So this effect can be explained by thinking of light as a stream of tiny particles. As I said before, light here you have to think about bouncing between two particles. Light is a particle, and electron is also a particle. We will have what? We will the result will be what? The emitting electron or particle of energy. Each packet of light energy is called what? A photon. Yes. Now light, the light consists of what? Photons, not particles or not electrons. Light consists of photons. If you said in the test electrons, I will give you a zero. Okay, light consists of light, X-ray, gamma ray, visible light, radio waves, ultraviolet, infrared. All of them consist of what? Consist of photons, not electrons. Okay, this point is very very important, and this is for today. Hoping that we will continue, inshallah, next time. And I expect from you to watch this video. If you have any question, you can find me on WhatsApp. Send me anytime you want. And see you next time, inshallah. Or before saying see you next time, I'm not in a hurry. This is the final chapter in our science curriculum. Okay, chapter 4 is not included in what? In this textbook. Okay, so in this textbook we have chapter 1, 2 and 3. So see you next time.